This is a quick video on a simple setup of Unitronics between two Unitronics PLCs using the Ethernet IP protocol. Again, it's a super simple one, but just wanted to share it. So this is just open the project, and within the first PLC, you can go to the physical layer where you set IP addresses, and because it's Ethernet IP, it uses the CPU address, not the panel address. And here's where I set up the protocol for Ethernet IP. It can be a scanner or an adapter. And in this case, I'm setting the adapter up, and we'll look at the scanner after this. So the adapter, this is from the PLC that had some I/O on it that I wanted to access from another. And so here's the adapter settings. It was pretty simple. You just clicked Add New Adapter and pop this up. And then it also populates these O2T originator to target and target to originator. It populates these numbers, and they may change once you set up some other information. So it's basically saying the outputs from this PLC are going to be this. This is I just named them a UCS struct, so it's several data points, and we'll look at the struct in a moment. And it's going to also have some originator to target, so it could share these. These could be coming back to it. So these would be outputs from this adapter. These would be inputs. And in this struct, this UCS struct, instead of having to put each different tag in there, you create a struct. You go down to structs, and you can see this one, UCS struct. Over here, and this is where you create the struct. Once you create a struct, you go to global tags, and you make a tag that contains that struct. So over here, in UCS struct, look at the name here, within this tag contains USC outputs. That is the name of back to structs. In here, USC outputs. If I click on this, it'll further expand what we are going to put in there as inputs or outputs. So I put in there digital outputs and one analog out. So you would select it, you create the name, and you say what type of information. If it's a bit type, for digital out is a bit type, and how many I want to share, 16. I would click save. It made this array. So if you first make the struct, and then you go to global and you make a tag, and within that tag contains the struct that you made. So that's the name over here. So created that. The output's going to share. The input's going to take from this scanner. So there's a scanner and an adapter. So we'll set up the adapter. You can go over and look at the scanner, which is a different project. So if I open my other project, so I didn't save anything in there, so I don't need to save it. I had another project that I just decided to put a screen on here to act as the scanner. So I created, all these are just related to a demo, and I created this other screen just so I could have an analog tag in here and I could take information, input it on the keyboard, and say load this new data. It'll communicate Ethernet IP and send it over to the adapter. And this is the scanner we're looking at. I also have this would be a discrete tag. If I press this, sorry, actually this is just to tell me the status of a discrete output. This one is one that I can send over, I can type a number and send it over. And this one's just displaying what is on the adapter. So the communication side of it, same thing here. You have the physical, and again, it's Ethernet IP. It's going to use the CPU address. So we had to type in an address here. This would originally be empty. I had to put an address over here and make it on the same subnet. And Then there's the different protocols available. In this case, we're going to be looking at the Ethernet IP, and it will show you this arrow means there's information contained under it. So in this one, you can see an adapter is not there. You can see I can set the scanner up because of this arrow. So we can expand it and look at the settings. So the scanner is the one that contains the IP address of the target. So you may have noticed on the other, the address was 192.168.28.124 for the CPU Ethernet address. So that's what the scanner is going to be looking for, this target. The struct, same thing over here. We created structs. We went to global, made a tag that contains the structs, and same kind of wording here: target to originator, and originator to target. And you tell it what you want to, what I want to output out of this device are these US7 outs. US7 is just the model of the PLC HMI, and I want to be receiving information into here. USC inputs, just you have the freedom to name these whatever you like. So I want to create the tags, and then again within the tags, within the structs, we name a tag to be contained in here. So if I go to global inputs, it'll look USC INS, so this one, US7 outs is that one, and within this are this USC inputs. This would be the struct name. So if I go back here, USC inputs. So again, you make the struct first, whatever you want in the structs contained here. Then you make the global tag. So once you put the IP address in here, I believe it handled the naming. This right here, let's see what the full name is. The instance naming, it took care of that. This is the how often you want to read write information. So you can change that. I just left it at the default. And I believe that's all. You can see there's some other information in there. I didn't have to modify any of this out here. But it did work nicely. It was very easy to set up. And I can get back to this. If I go out to actually look at the project, I can say, let's open a VNC viewer. Just a quick explanation of a struct. Structs contain sets of information that you're going to use. So just if we want to make a new struct, you have the navigation tools at the bottom. New struct, can have the freedom to name it wherever you want. Typically going to name it something that means something to you. So outputs. From PLC, could be whatever you want. And what are we going to output out of this PLC? Say digital outs, and let's say it's just bit data, and you want to look at just 8 bits you want to share. Say add. So now within our struct that we named outputs from PLC, we have a set of digital outputs and an array of 8 bits, 0 through 7, be 8 bits. Say we want to share an analog tag, and you can name it whatever you want. Just name it analog outs. What type? In this case, it's going to be an integer value, 16-bit integer. And we're going to say add. And when you're finished, you can just say save or close. So now, outputs from PLC, these 8 bits and this one 16-bit integer are contained in this outputs from PLC. Now, to use that in this Ethernet IP example, you go over to global and you need to create a new tag here. So when they say new tag, and we'll say, again, you can name it whatever you want, outs from PLC. And this time, when you scroll down the list, there are the structs that we made. Just that, and we're going to say save it. Now, when I when I'm setting up something, instead of having to drag many tags over, you're able just to drag the one tag that contains a struct that has uh, many tags within it. So, like on these examples I was working on earlier, this, I would be able to, in here, instead of doing each individual tag, I can go in and from the list now, it would be contained in here, the structs. There's a struct, there's a struct. Um, and what would we name that one? Outputs from PLC. And it's giving you an option of which outputs, just the digitals, just analogs, and it's because there's a dot there. If you just back up and hit enter, now it's taking the whole complete struct. Yep. Okay, now we're looking at the one of the HMIs that I shared this address on for the Ethernet IP. So if I navigate to a screen, I add an extra screen just to demonstrate Ethernet IP. These are the tags, so it's reading level from over on this guy. So if I change the level here, I should see it change on this display, and I do. So let's read it, and if I want to write some information back from this panel, say I want to load 20% back over, it's sent the 20% back here, and you can see pump status. So this status tells you if the pumps are on or off. So if I simulating a tank level, tell me the tank is 99% full, and I I've just put it in there, but I haven't sent it yet. I'll send it over. It's telling us to turn some pumps on to try to pump it down. And so there we go.